Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about quadratic regression based on application problems, so real-life problems where we could use quadratic regression. This is going to be a very calculator-heavy video. There are ways to solve this without a calculator, obviously, of course, but they are much longer. I'm showing you the shortest way, so I'll try to point out how you could solve these by hand as we go if you were in a situation where you didn't have a graphing calculator. But using the graphing calculator is so much shorter, and it's such a great shortcut. I really want to focus on how to know how to do that. This data table represents the money in Peter's savings account over the years. So here we've got a year. In the year 2000, he had $100 in his savings account. In the year 2001, he had $200. Now we jump a couple years down to 2003, okay, and in that year he had $350. We jump a few more years to 2006, and so on. So you get the idea that this was the year, this was the amount in his savings of that particular year. I guess at the end of the year when they looked, that's how much was there. The first thing that they ask us to do is to write an equation that represents this quadratic data. And we are going to actually be writing our own quadratic equation. So up to this point, we've really been dealing so much with quadratics and equations that have been given to us. Now we are going to actually take real data and write an equation on our own. So that's pretty cool, I think. So the first thing we're going to do here is we're going to get our calculator out. And we need to, in order to come up with this equation, we need to input this data so the calculator can tell the pattern of what's happening here and translate it into an equation for us. So we're going to start by going to Stat, and we want to edit. So you want to hit Enter. Now you'll notice we've got L1 and L2. This stands for List 1 and List 2. And we're going to fill up these two lists with these two columns of data. Okay, so in list 1, we're going to put our time, all of our X values, and in list 2, we're going to put all of our dollar amount values. Now, something different about this problem in particular is that it's given us years. A common student temptation is they want to put in 2000 for their first X value. And we can't do that because our calculator doesn't understand that we're talking about a year, not a 2000 value. So we are actually going to make this year 2000, that's going to be our year 0. That is the first year that we are collecting data. So we're going to call it 0. And usually on these types of questions, they would have a statement after this. It would say, and I'll show you the kind of statement they would show. Let year 2000 equal 0. So it's saying that's your starting year. We only have to do this little second step when we're talking about years or months or something really different. We'll look at examples both with years and an example without years. All right, so if year 2000 is year 0, what would be 2001? Well, 1 year will have passed, so that's 1. Okay, so if 2000 is year 0, what would be 2003? Well, at that point, it wouldn't be year 2. That'd be 2002. This would be year 3. 3 years have passed since the original starting year. Now, what about 2006? Well, that would be year 6. And 2010, if 2000 is 0, then 2010 would be year 10. 2015, that would be year 15. So what we're actually going to put in our calculator is not 2000, we're going to put in 0, okay? And then we're going to put in 1, 3, 6, 10, and 15. It's always worth a second look just to look back through and make sure you didn't make any errors, because if you mess up even one of these numbers, it'll change your whole equation. All right, now let's put in list 2. Now for this one, I don't need to do a translation amount. That's only, again, if it's years or months or something kind of different, okay? If it's just a dollar amount, we're just putting in the dollar amount. 100, 200, 350, 785, 1,110, and 2,000. Okay, so look back through, make sure you got all your numbers typed in correctly. You should have an even amount. So in this case, we have 6 pairs of data, 6. And from here, we want to hit Stat, and we want to move right over to the Calc. Now, I've already told you this is quadratic data. So we want quadratic regression. Okay, we are going to write a quadratic equation. So that's number 5 is quadratic. And we want to hit Enter, 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 Enter. And here is our equation. So it gives us the standard form of a quadratic first. Y equals ax squared plus bx plus c. And it tells us what a is, what b is, and what c is. Now, of course, when I'm writing this, I would want to round, right? I don't want to hand write my equation on my paper with all these decimals. That's way too much. I want to show enough decimal to be specific, but not this entire long decimal. So I would round, I don't know, maybe 2, 3, 4 places, depending on what your instructions tell you. Here, we'll just go 2 places. So we'll say this is, write an equation. So we'll say y equals 3.14, and then we have our x squared plus, it's positive, 76.97, we'll round up, x plus c, which is 114.41. Okay. So now we've written an equation that expresses this quadratic data. Now it says to the nearest dollar, what will the account be worth in 2025? So it's kind of like we're adding a row onto this column. We're saying in 2025, how much would this be worth? We've got to think, I'm looking for my y if my x is 2025, but I've got to be careful. What would be my year amount in 2025? Well, that would be, if 2000 is year 0, 2025 would be year 25. There are 2 ways that I could go about this. I could either solve this manually. I could put in 25 for x, type it into my calculator, and have it solve it for me. And let me show you how that would look. I would do y equals 3.14 times 25 squared plus 76.97 times 25 plus 114.41. That's how it would look, and I would manually write that into my calculator and solve it. Wouldn't be hard. That's definitely one way to do it. I'm going to show you an alternative way, okay? I'm going to go to my y equals, and I'm going to type this in, not this. I'm going to type this in, the original with the x's. So 3.14 x squared plus 76.97x plus 114.41. Okay, I want to go to my table from here, second graph table. Okay, so this takes me to all my table of values. Now I would want to know when x is 25, what is y? So I can scroll down to where x is 25. Okay, and what is my corresponding y value? $4,001.20. We'll just round it to the nearest dollar. So we would say the dollar amount is $4,001. Now, let's be very clear about something. This is just a prediction. This is a prediction based on past history, based on past data. This is where they predict the account will be that it will have $4,001 in it by year 2025. That's just at the current rate. It's important to note that equations don't necessarily, they don't know the future, okay? There's lots of things that could impact Peter's savings account over the years. He could come into a very large inheritance and put a ton of money in there. Or he could have some type of, situation happen and he needs to pull money out of the savings account. And so he would be starting again at zero. So there are things that happen in life. So this is purely a prediction. It's not a guarantee. I could plug this in, solve it manually, or I could use my table of values to help me, okay? Either way. When will the account have approximately $1,645.50 in it? When? So they're wanting to know at what year will the account have this much money in it. So we're looking, when would the account have $1,645.50? When would that happen? What year would that happen? There are two ways to go about doing this. The first way would be to plug in $1,645.50 for Y and solve for X. And let me show you how that would look. So we would say $1,645.50 equals this equation, 3.14x squared plus 76.97x plus 114.41. And we could manually solve this equation for x. You would want to get your 1645.50 over to combine it with the c, and then at that point it's a quadratic equation, and I would definitely recommend using the quadratic formula to solve it. That is very time consuming. You can do it, absolutely. I did it when I was checking this problem, okay? So this is where I love having the graphing calculator, because I can look and say, all right, well, let me see in my table of values if I can find where 1645.50 is, and let me see if I can figure out the corresponding x value. So right now I'm at 4,000, so I'm way too high, right? I want to go further down. And so I want to go down to where I see 16. Okay, so I see right there 1645. Now this one says 0.7 and this one says 0.5, and that's okay. It says, when will the account have approximately? Approximately just means about. So it's okay that it's 20 cents off. That's perfectly fine. When will that happen? Well, let's see what year that would be. X is 13 when Y is 1645.7. Let's think about, if X was 13, right, because that's our X value, what year is it? What is 2000 plus 13? Well, that's 2013. So when they ask, when will the account have approximately that much money in it? 2013. And here, I should have written my formal answer up here, that it is 4,000. Let's look at another example. The following chart represents car speed in miles per hour compared with fuel use in miles per gallon. Okay, so we've got our speed, so this would be 17 miles per hour, 20 miles per hour, and so forth. And then comparatively, the fuel use when used at that speed. So in this particular car, if you're going 17 miles per hour, your fuel use is 21.4 miles per gallon, each corresponding value. This is quadratic data. We first want to write a quadratic equation that fits this data, and it specifically tells us round 4 decimal places. Okay, so that's 10,000ths place. So the first thing we want to do is bring our calculator over, and it's a good idea to go ahead and clear it to get out any of that old list data that you've been working on with other problems. So anytime we're doing quadratic regression, or really any type of regression, I usually will just clear my calculator at the start of a new problem, just to get rid of all the old lists. I would want to go stat. We want to edit our lists, so we'll hit enter under edit. we're going to put under list 1, we're going to put all our x values, and under list 2, we're going to put all of our y values. Now, on the last problem, we had to translate our years into a number value. It's important to note, I don't need to do that here, okay? I only am doing that if it's something like years or months or something really quirky like that. Okay, here they're just giving me values. So here we go, 17, 20, 27, 33, 45, 58, 67, and 70. It's always worth the second look to look back through and say, did I make a mistake? Because if you make a mistake, better to catch it early than later. All right, now let's input our list 2, 21.4, 24.2, 25.7, 26.1, 30.1, 28.2, 27.3, and 25.4. You definitely want to look back through when you've got a lot of decimals going on. And you also want to double check to make sure you have an even amount of pairs, so you haven't accidentally skipped one. Okay, now from here, we want to go to Stat, move over, write 1 to Calc, and we want that quadratic regression. We want a quadratic equation, so we hit number 5. Enter, 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 enter. And there's my quadratic equation based on this given data. So let's go ahead and write this down. It told me to round 4 decimal places, so I'll be careful to do that. Y equals, A is negative 0.0073 if we round 4 decimal places. And then we'll add in our x squared, that's part of the equation, plus 0.7098, and then just our x, and then our c, plus 11.8997. At this point, we've gotten our equation written. The next thing they ask is predict the fuel use when driving at a speed of 47 miles per hour. If our speed was 47 miles per hour, what would be our predicted, and the key word there is predicted, it's just a guess, what would be the predicted fuel use of the car? So if x was 47, what is our prediction for y? There's 2 ways I can do this. I can either manually do it, and I'll show you how that would look. I could either say y equals negative 0.0073 times 47 squared plus 0.7098 times 47 plus 11.8997. And I could plug this in my calculator and solve it. That is one way. Another way is just to use my table of values to help me out. And this is especially helpful if you've got a lot of questions asked of you. I would say any more than, 1 question, I would use the table of values. So we go to y equals, and we're going to type in this equation, the original equation, not this one with the 47 plugged in. We want this one. All right, so negative 0.0073 x squared plus 0.7098 x plus 11.8997. It's really easy to make a mistake, so it's worth looking back through, making sure that you've typed it in correctly, that you've put decimals where there need to be, negatives where there need to be, otherwise your answer will be wrong. Okay, let's go to second graph. Let's look at this table of values. I would want to know when x is 47, what is y? So I'm going to scroll down to where x is 47. Now some people may say, I don't want to scroll down that much. I don't want to have to do all that. That's fine. Then maybe this is your method that you want to stick with. But for me, I'm just going to scroll down to 47. It's not too far. Right there. So when x is 47, I see that y is 29.135. So we will just say that when X is 47 miles per hour, the miles per gallon is 29 point, and we could round this to 0.1 miles per gallon. Okay, so when X is 47, Y is 29.1. Our next question asks, what is the lowest speed you can drive to get a predicted fuel use of 19.4? Okay, so we're talking about fuel use. So if my predicted fuel use was 19.4, if my fuel use was 19.4, what is the predicted speed that I'm going? What's the lowest speed I could go and get that gas mileage? Basically, I'm plugging in for Y 19.4, and I'll show you how you could write it out manually if you wanted to. Negative 0.0073 x squared plus 0.7098 x plus 11.8997, right? And I could solve this for x by hand if I wanted to. I would want to subtract the 19.4 to combine it over here with my c, and at that point I'd have a quadratic equation. I would definitely use the quadratic formula to solve that quadratic equation, and you will get the same answer that we would get if we wanted to use the table of values. Now, I find it much quicker and easier to just use the table of values, so that's why I'm kind of a big proponent of doing this. So let's see, when Y is 19.4, when is the lowest place? Well, right now I'm at 28.83, so definitely want to move up, right, to get my numbers lower. I'm looking for 19, so I'm going to keep going. Oh, here's 19. Okay, so when would we be at approximately 19.4? Well, that would be right here, 19.366. That would round to 19.4. At what speed does that happen? 12. So we would have to be going 12 miles per hour to get a predicted fuel use of 19.4. 12 miles per hour. That would need to be our speed. Okay, here's one for you guys to try. So it says a catapult launches a rock. The data below shows the distance the rock travels when launched at different angles. Here we've got various angle degrees, and then we've got the distance traveled when launched at those angles. So the first thing that I want you to do is write an equation that represents this quadratic data. Go ahead and round 3 decimal places this time. And then the second thing I want you to do is say that if you set an angle to 27 degrees, so if X was 27 degrees, what would be your predicted distance in yards? So if X was 27, what would Y be? I will post the answer in the video description below. This has been Miss Smith's Math Tutorials.